Welcome to VEROSIM X in the Loop with VEROSIM Digital Twins. VEROSIM Digital Twins are the answer to the question what if? What if my autonomous vehicle runs into a traffic jam? What if my camera sensor is soiled and detects a braking car too late? All of these questions arise in the development of highly automated systems, especially in, but not limited to, the automotive domain. Since the X in X in the Loop can stand for nearly everything, ranging from software, hardware, over the human, or even the complete vehicle as depicted here, we use application-independent as well as highly modular digital twins to be integrated within our virtual environments. Taking a look at the real vehicle, it comprises various components to be modeled appropriately. Therefore, a digital twin comprises and takes care of the simulated physical system, the simulated information processing system, as well as the simulated communication infrastructure and HMI. Fusing all of these components into a single representation, which is the VEROSIM digital twin, we achieve a one-to-one representation of the real twin of the real vehicle. This is not limited to a single vehicle, but also holds for further objects of the real world. This includes further cars, the street, the crossing, buildings and cranes, as well as traffic lights and so on. Having all of these digital twins within our repository, we can combine them to create a virtual test scenario. This is done by connecting them either explicitly, for example, connecting them via the simulated communication infrastructure, or implicitly by putting them into the same dynamic environment, which ensures that objects collide with each other, as well as camera sensors mounted at, for example, the ego vehicle perceives the surrounding traffic, the surrounding trees, and so on. Afterwards, this virtual test scenario is put into our VEROSIM platform, the 3D simulation platform, which provides as well as integrates different simulation algorithms. This includes physical sensor simulation, dynamic simulation, as well as HMI interfaces and communication infrastructure within the virtual test scenario, but also to the real world, for example, to include real hardware for hardware in the loop. By iterating over all of these simulation algorithms and all of these software components, VEROSIM brings digital twins to life. So the ego vehicle is driving on the road, the camera sensor mounted in the front is perceiving the surrounding traffic, can be used, for example, for traffic sign detection, and traffic lights are controlling the traffic flow, and everything behaves as in the real world. Our overall goal is to ensure a seamless transition between simulation and reality. This implies a continuous as well as application-specific validation of the simulation itself, in this case for the camera sensor simulation. Here we are comparing the real world, this is a real record from a real test drive on the top, to a simulated camera record on the bottom. Here we are using surf features to have a metric for comparison which are tracked over time. Talking about realism, the real world is not always perfect. It also includes obstructed lens systems or broken road markings. Both are also simulated using our digital twins, as can be seen in this simulated record. So we see a soiled lens system on the top corner, as well as broken road markings on the ground, both of which are generated using a procedural approach which reduces the effort of manual modeling. We are not only simulating camera sensors, but also lidar sensors, which are really important for highly automated driving as well. And here we are not focusing on single manufacturers, but we want to provide a very generic as well as physical sensor simulation, which can be parameterized and configured to mimic a wide variety of sensors, sensor types, for example camera and lidar, as well as sensor versions, for example a multi-layer lidar sensor, as well as flash lidar sensors from different manufacturers. This holistic approach has been honored by the AutoSense Awards with Silver Award for Most Influential Research. To underline this holistic approach, we take a look at the space sector. Here VEROSIM is used to optimize a lidar-based rendezvous and docking system for an automated docking of a satellite system on the left and the International Space Station in the middle. VEROSIM provides the chance to test everything, the complete mission on ground in a safe and virtual environment to ensure that everything is running fine in the real mission when the satellite system docks to the International Space Station. Same holds for the industrial domain. Here VEROSIM provides, for example, the simulation of complete production plants, including driverless transport systems which are navigating through the halls using a fisheye camera, where a simulated one is depicted on the top left corner, as well as lidar sensors. And camera-based inline inspection system, for example, can be tested and can be analyzed regarding capabilities to ensure the quality of the product. And both is done even before the real production plant is built or even without stopping the production. VEROSIM is not only a simulation. VEROSIM provides you the chance to get into this virtual world using, for example, a multi-sided backscreen projection, which really gives you immersive feeling to stand right next to this digital twin. Maybe you can sit next to a digital twin on a bus stop and look at the virtual scenario. Taking a seat in a simulated harvester can be very exciting as well. In this case, you get visual feedback as well as force feedback by using our motion simulator. This can be used to train harvester drivers to make sure they make mistakes only once and hopefully only once in simulation using our VEROSIM digital twins. For example, flipping the harvester upside down, giving you the feedback of rolling over the ground. Finally, our fields of applications are wide, ranging from the optimization of sensor-based systems, the analysis and test of intelligent systems, the training of neural networks using simulated sensor data. But we are not doing this on our own, we are doing this with partners from research and industry. To this end, we provide 3 layers of collaboration as well as cooperation. It starts with the MMI of RWTH Aachen, responsible for research and research contracts. It goes up to the RAF located in Dortmund, responsible for the technology transfer as well as the development of proof of concepts. Finally, we reach the VEROSIM Solutions, responsible for applications as well as services. We hope you enjoyed this presentation and thank you for your time.